Zulaikha, what are you listening to?
Oh, I'm listening to Magnetic from Ili.
Magnetic? I think that sounds very familiar. I think we have to learn about it in physics, right?
Yes.
You're right.
But I really don't understand about a topic called magnetic field produced by a current.
Oh, that's easy. There are 3 types of current carrying conductor that produce different magnetic fields. First, we have straight wires. Second, we have solenoid. And third, we have circular loop.
That's the one that using the Biot-Savart law, right?
The Biot-Savart law is the law that can be applied to determine the magnetic field they produce, which are long straight wire, circular loop, and solenoid. Now we will see what is actually the Biot-Savart law. The Biot-Savart law is a fundamental principle in electromagnetism that describes the magnetic field generated by a steady electric current. Therefore, the general formula for this Biot-Savart law is dB equals to mu naught over 4 pi times with I times dl times sine theta over r squared. Then when we integrate both sides, we will get B equals to mu naught over 4 pi times with integration of I times dl times sine theta over r squared, where the mu naught over 4 pi is the constant value. Next, the Biot-Savart law states that the magnetic field strength B at a point in space due to a small segment of current carrying wire is directly proportional to the current I, the length of the wire segment dl, and the sine of the angle theta between the wire segment and the line connecting the segment to the point where the field is being calculated, and it is inversely proportional to the square of the distance r between the wire segment and the point.
Long and straight wire, the magnitude of magnetic field can be found by using this equation. B is equal to mu naught multiplied with I over 2 pi r. From the equation, magnetic field B is proportional to the current flowing through the conductor. Magnetic field is inversely proportional to the distance from the conductor, and the direction of B at any point along the field line is tangential to the point. The direction of magnetic field and also current can be determined by gripping the wire and using the right hand rules. If the wire is grasped in the right hand with the thumb in the direction of the current, the finger will curl in the direction of the magnetic field. So, this is the current flow direction and this is the magnetic field flow direction.
Now, let's look at magnetic field inside a solenoid. The magnitude of magnetic field at any point inside a solenoid can be calculated using the formula B equals to mu T times mu naught times N times I. However, we can also substitute N divided by L. Meanwhile, the magnitude of magnetic field at the end of the solenoid is half the field at the center and can be calculated using the formula B prime equals to 1 over 2 times B, which also equals to mu T times mu naught times small n times I, and divided by 2. When an electric runs through the wire of a solenoid, the magnetic field is created as shown in the animation. The pattern of the magnetic field is similar to a bar magnet. The magnetic lines are almost parallel inside the solenoid and is directed from south pole to north pole. In order to find the north pole and the south pole, we can look at the circular end of the solenoid. If the current flows in anti-clockwise direction, then the end is north pole. It can be remembered with the help of the symbol of anti-clockwise direction, which resembles the letter capital N. On the other circular end of the solenoid, if the current flows in the clockwise direction, then it is south pole. It can be remembered with the help of the symbol of clockwise direction, which resembles the letter capital S.
This is the diagram of magnetic field for circular loop. Let's say I want to see how the magnetic field looks like in this section. You can use right hand grip rule. Clasp your right hand to this section so that the thumb points in the direction of the current. If you follow the arrow in the middle, the current enters the screen, and so the thumb should be pointed into the screen. And the 4 curling fingers give the direction of magnetic field around that section. And the fingers are running clockwise. Similarly, if I consider this section, you will see that the current comes out of the screen at this section and then goes to the right, meaning that the thumb will be visible. So apply the same right hand grip rule and this is how it will look like. And the encircling fingers will go anti-clockwise. Now, to figure out magnetic field for anywhere else, you don't have to keep doing it over and over again and make your job difficult. So if you look at the magnetic field for each corner of the loop, you'll find out that the inner loop has it pointing upwards, while the outer loop has it pointing downwards. And so, it should be looking like this. How can we find the magnitude of magnetic field in circular loop? So there are 2 formulas. One is for the regular circular loop, which is B equal to mu naught I over 2R. If there are number of N turns, meaning that the wire is coiled around repeatedly, you need to use B equal to mu naught Ni over 2R.